So this is 2025 paper 1 question 1, and we're asked to solve this inequality. So I think the way that most people will learn to solve this is to square both sides, and the reason for that is because if we have the absolute value of x minus 3 squared less than or equal to 12 squared is 144, well then the absolute value of x minus 3, when you square that, it's always going to be positive, so we don't need to worry about whether it's positive. We don't actually need the absolute value because the square there is going to ensure that it's positive anyway. So we can actually just write it as x minus 3, the whole thing squared, less than or equal to 144, because this is always positive anyway, so we don't need to worry about the absolute value. So then you can multiply out that bracket and you'll get x squared minus 6x plus 9 is less than or equal to 144. We can bring everything to the left side, and what you'll get is you'll get that x squared minus 6x minus 135 is less than or equal to 0. So the way that we figure out whether this quadratic is less than 0 is by doing a little quick sketch. And you can see that this quadratic, it's positive quadratic, so it's going to kind of look like this somewhat. Again, not really drawn to scale. But basically, we want to find one that's less than 0. So again, if this is the graph of y equals x squared minus 6x minus 135, we want that to be less than or equal to 0. We're looking for when the y value is less than or equal to 0. So that's essentially all this space in the middle here. So we need to figure out where the roots are, or where it crosses the x-axis, which I'll draw these little green points. So let's figure out what the roots are. So let's solve x squared minus 6x minus 135 is equal to 0. So factors, you can use the quadratic formula if you'd like, but factors of 135, you have 9 and 15. So if we use minus 15 and plus 9, we'll get the minus 6 in the middle. So we'll have x minus 15 times x plus 9 is equal to 0, which means that x is either equal to 15 or x is equal to minus 9. So I guess we can say that this green point here is minus 9, and this one here is 15. So in order for the y value to be less than or equal to 0, that means that the x value has to be in between minus 9 and 15. So if we have our x value, it has to be in between minus 9 and 15. And that is our answer for the inequality. Another nice way of doing it that's a bit more intuitive is if you think about a number line, let's say this is 0, and let's say here's minus 12 and here's 12, the modulus basically means the distance between 0 and that number. So basically you want the distance between x minus 3 and the origin to be less than or equal to 12. So that means that the value of x minus 3 has to lie somewhere in here. Because again, if it was like over here at say minus 15, then the distance from the origin to 15, well, that's going to be equal to 15, so that's obviously bigger than 12. But we want the distance to be smaller than 12, so it has to be between minus 12 and 12. So we can say that the value of x minus 3 has to be in between minus 12 and 12, and if you just add 3 to all sides, you'll get minus 9 less than or equal to x less than or equal to 15. And that's a much faster and more intuitive way of doing it. In part B, we're asked to multiply out and simplify this expression. So basically, we're just going to take the first term here, and we're going to multiply it by everything in the second bracket, and then take the second term and multiply it by everything in the other bracket. So I'll color code it to help. So 4x times 2x will give us, so 4 times x times 2 times x, that'll give us 8x squared. 4x times 5 root x will give us plus, and we're going to have 20x root x. And then we're going to have 4x times minus 7 will give us minus 28x. We're going to have minus 10 root x times 2x will give us minus 20x root x. So we'll have minus 10 root x times 5 root x. So we're going to have minus 50 as the number, and then root x times root x will give us just x. And then the minus and the minus will make a plus here, and then 10 by 7 will give us 70, and then we just have root x. Now what we can do is we can collect like terms. So you can see here we have an x root x term, and here we have an x root x term. They actually quite nicely cancel each other out. We also have minus 28x, and then we have minus 50x, so we can also combine those. So we're going to have 8x squared, and then we're going to have minus 28x minus 50x will give us minus 78x, and then we're just going to have that plus 70 root x, and that is our answer. In part C, we're told a factor of a cubic and told to use that to find 3 solutions to the cubic. So you could use polynomial long division here, but what I prefer to do is say that if we have this, if this is a factor, that means that if we multiply this factor by something else, which is going to be a quadratic, because we want it to be a cubic, linear times quadratic gives cubic. So we don't know what the quadratic is, it's ax squared plus bx plus c. That'll be equal to the cubic. 12x squared minus 7x plus 30. So basically, when we multiply that factor by some other factor, which is a quadratic, it'll give us the cubic. And now we just need to figure out what a, b, and c are, and then we can solve this quadratic, or solve this linear equation as well, and they're the solutions to our cubic, because this thing is the exact same as the cubic. So we can kind of use a little bit of intuition here to figure out what a, b, and c are. Well, we can clearly see that the number in front of the x cubed is a 4. And the only way we're going to get an x cubed from this left-hand side is by multiplying this x term by this x squared term. So that means 2x times what will give us 4x cubed. Well, if we had 2x times 2x squared, that'll give us 4x cubed. So we can make the assumption that a is equal to 2. Again, if this doesn't make sense, we can actually do it out a longer way. I just want to kind of give you a bit of an intuition for how this works. And similarly, there's only one way we can actually get a constant here. So you can see our constant over here is 30, and everything else it'll have an x, except for 3 multiplied by c. That's the only thing that's going to give us a constant. So that means that c must be 10, because we need 3 by 10 to give us 30. So again, we're also going to be thinking that c should be 10. Again, if you didn't spot that, that's completely fine. You're going to see it'll actually all work out now. So I'm just going to multiply out the left-hand side. We're going to have 2x times ax squared will give us 2ax cubed. Then we're going to have plus 2bx squared plus 2xc. Then we're going to have plus, and then we're on to the 3. So we're going to have 3ax squared. And we're going to have plus 3bx, and we're going to have plus 3c, and that's equal to the cubic. And now we know the number in front of the x cubed, the number in front of the x squared, and so on. So let's group all these together. So the number in front of the x cubed is just going to be 2a. The numbers in front of the x squared, well, you can see we have this x squared and we have this x squared. So if we factor out an x squared, we're going to get 2b plus 3a x squared. And then what number is going to be in front of the x? Well, we have this with an x and we have this with an x. So factor out an x, we're going to get 2c plus 3b multiplied by x. And then we have plus 3c, and that's equal to the cubic. So you can see on the left-hand side, the number in front of x cubed is a 4. So that means that 2a is equal to 4, or in other words, a is equal to 2, as we predicted up here. Again, so it doesn't matter if you didn't spot that, because we can kind of figure it out now. Another easy one, you could go on to this term, the x squared terms, but just another easy one to spot is that we have 3c and 30 here. They're the only constants. That means that 3c has to be equal to 30, which implies that c is equal to 10 if you divide by 3 on both sides. Again, as we predicted, but it doesn't matter if you didn't see it. Predicted, I mean. Because we can just figure it out like this. And then it doesn't really matter what one we do next. It's actually good for a check. But if we look at the numbers in front of the x squareds, we know that 2b plus 3a should be equal to minus 12. And we know that a is 2. So 2b plus 3 times 2 will give us 6, which should be equal to minus 12. So what we're going to get is that 2b equals minus 18. So b is equal to minus 9. And a good check we can do on these types of questions is we can actually just do the last one. Even though we already know a, b, and c, this will check to see if we're right. So we know that 2c plus 3b will be equal to minus 7. Let's see, just to check that our values are correct, let's see if that's true. So 2c is going to be 2 times 10, plus 3b is 3 times minus 9 equals minus 7. Is that true? Well, let's check. We'll have 20 minus 27 equals minus 7. And that is indeed true. So we know that we haven't made a mistake so far, or we probably haven't made a mistake so far. So let's just take down the original statement that we had here, except now we know that a is 2. We know that b is minus 9, so we'll have minus 9x. And we also know that c is equal to 10, so we have plus 10. So instead of writing the cubic, we can also write it in its factored form like this, and we know that's equal to 0. So that means that this factored form is equal to 0. So if we have two things multiplied together and it's equal to 0, either the first thing 0 or the second thing 0. So either 2x plus 3 equals to 0, which implies that 2x is equal to minus 3, which means that x is minus 3 over 2. That's our first answer. Or we have that 2x squared minus 9x plus 10 is equal to 0. So here we can look at factors of 20, because 2 by 10 is 20. So that's kind of the factors we're looking at. And factors of 20, well, we can write that as minus 4 times minus 5. And if we do minus 4 minus 5, that gives us minus 9x. So that's a good one to look at. Again, you can just use the quadratic formula if you want. But we can write this as 2x squared. And instead of writing minus 9x, we're going to write minus 4x minus 5x. Then we'll have plus 10 equals 0. And then we can just factor some things out. So the first two terms, you can see they both have a 2x in common. So let's take that out. So we'll have 2x times x minus, we'll have 2. And then what we'll have is we'll have plus, and these both have a 5 in common. So let's go for 5, and then we'll have minus x plus 2. So you can see we're very close to getting it to work. They both have an x minus 2, except this one is just off by a negative. So I can just factor a negative out of this. Again, if you don't like this way of solving quadratics, you could just use the quadratic formula. This is just the way that I'm doing it. So if we write this instead as a minus 5, and then we write x minus 2 equals 0. And again, we can do that. It's just like factoring out a minus 5 instead of factoring out a positive 5. Or just think about factoring out a minus 1 from this. And then we're going to get positive x and minus 2. So we're basically kind of flipping the signs. And then these both have an x minus 2 in common. So we're going to have x minus 2. And then we factor out the x minus 2, and we get 2x minus 5 is equal to 0. So that means that either x minus 2 equals 0, which implies that x is 2. So there's another answer. Or 2x minus 5 is equal to 0, which means that x is equal to 5 over 2. And that's it.